unchain today. We're going to take antiderivative of things that are the result of chain rules. And the more you do, the better you get at this. Initially, it's really hard to see how things came about. The more practice you get, I guess this is always true, the more practice you get, you start to recognize what's going on. When you take derivatives of more complex expressions, again, that was the warm-ups, you frequently have to use the chain rule to differentiate. That's why I picked the two things we did to take derivative of. They both had chain rule stuff. And that means we got complicated answers. And so the integration equivalent of the chain rule, if we want to go backwards, is U substitution. It allows you to integrate more expressions. The U is arbitrary, so we just make up the U. You could just as easily have called this V substitution or W substitution or any letter you like substitution. But every calculus teacher everywhere, probably not every calculus teacher everywhere, but every calculus teacher uses the phrase U substitution.
Every calculus teacher you know.
Correct. I don't know all of them. Okay, the key to remember is you must replace all x expressions with u expressions. That's the big thing. Like the error is to go sort of halfway and you end up with some x's and some u's, and then you're really messed up. You got to commit and get all the x's out, replaced with u stuff, including the dx. Okay, and we pick the u. Here's the best way to say this. Picking the u is by far the most important thing. Like, how do I know what to make u? Practice, practice, practice is the short answer. But the hint is pick u so that du is part of the integrand. Pick u so that du is part of the integrand. Integrand meaning the thing that you're integrating.
We are calling it an antiderivative thing?
Yeah, you could easily call it as part of the antiderivative. No, because you're taking an antiderivative. Don't want to call it that. Pick u so the du shows up. You'll see what I mean as we go through this. And so you kind of have to think ahead when you're picking u. All right, you got to sort of mentally think, if I let u be this, then what's du, and then check to see if du is there. And if it is, then you're good. So that's a couple of steps in your head before you write anything down. As we get going, we will occasionally miss on who u is first, and that's fine. That happens. It won't happen initially, but later on we get to the harder stuff. You'll think u is this, and it doesn't really work, so you go back and try something else. And that's okay. That's part of the process. Like it's an iterative process sometimes, meaning it's a little bit of guess and check. Pick something. If it works, great. If it doesn't, you didn't fail. It means try something else. All right, number 1. Integral of x times x squared minus 1 to the 5th dx. Okay, so I want u to be part of the integrand so that du shows up, preferably in some other part of the integrand. So you don't know, it's the first one. You probably don't know what u should be yet. But if I let u be x squared minus 1, so this inside part right here, then what's the derivative of x squared minus 1? 2x. Now, we do something, we'll do it once formally, and then we kind of pass over this the rest of the time. But really, du dx is 2x, the derivative of u with respect to x. Which means that du is 2x dx if we move that dx to the other side. Okay, so let's see where we're at. This part is u, so I've got u to the 5th. And then I have an x and a dx. trying to match it up. That's close.
You have to change it to U.
I need a 2 there, because if there was a 2 there, I'd be set. So I'm going to do this little trick where I put a 2 there. And if that feels kind of like, wait a minute, that's not legal. You're right. If that's all I did, that's not legal. Like, you can't go changing problems to make them work, right? Like, that'd be nice if you could, because you'd have done that way back in algebra and just like make everything a nice problem. So I cannot really do, if that's all I do, I can't do that. But if there's something I could do that would sort of counter the effects of multiplying by 2.
Multiply everything by 2?
Well, if there were 2 sides of an equation, I could do that. Like if this was equal something, I could put times 2 on the other side. That's true. But I don't have that.
But 2x equals to u dx.
I could divide by 2. And on some level, it's like, well, what's the point of multiplying by 2 and dividing by 2? Except that now it matches up. Now this 2x dx, that's du. I still have this 1/2 out front. But I don't mind a 1/2 out front. I can deal with that. And then on the inside, I have x squared minus 1, but that was u. U to the 5th. Well, I hope you think this is very good news, because I can integrate, I can antiderivative u to the 5th.
Yes.
That's pretty easy, or should be easy. A whole lot easier than this original thing was. So let's take the antiderivative of u to the 5th. So if I antiderivative u to the 5th, we can pick on some people today. Austin, what's the antiderivative of u to the 5th? Yes. U to the 6 over 6, and then we still have that 1/2 out front. All right, I don't want to say Austin was wrong, because he wasn't wrong. He just didn't kind of finish. Is there anything I'm missing off of that? The antiderivative of u to the 5th is u to the 6 over 6 plus c.
Because we didn't get boundaries.
Yes, that's right, because we didn't have boundaries. We'll do boundaries tomorrow. So 1/12 u to the 6 plus c, except that, like, that's an okay answer, kind of, but this problem started with x's, so I need to end it with x's. So this is not finished yet.
U equals x squared minus 1.
But u is x squared minus 1, so I can now put x squared minus 1 back in for u. And now I've got an answer. So we u substitution. We changed a really complicated integral into a much easier integral with u substitution. And that's how it's supposed to work. You're supposed to start with something really ugly and then land at something that's okay. Or at least better. Again, it just takes time and practice until you get better at figuring out what u should be. So we've only done one. I'm not going to call a popsicle stick on this. Any idea on what u could be for number 2?
6x minus 1.
Let's try 6x minus 1. And you kind of have to find the right balance of, you want u to be enough stuff to simplify things, but if you make it too complicated,
then it just makes it worse.
yeah, if you let u be 6x minus 1 to the 2/3, then du is a really big mess and it's not going to work. So you've got to find the balance of, I want u to be some stuff to simplify, but if I make it everything, then it gets ugly. So there's not really a good answer to do that automatically other than practice. All right, what's du equal to?
6dx.
6dx. We really stopped putting du dx. We just automatically move it to the other side. Okay, 6dx. I don't have 6dx.
But you can multiply by Something.
Okay, so there's options here. I can multiply by something. 4 times something would get me to 6.
Yep.
Yeah. I mean, it is 3 halves, but I don't want
Don't want to touch
to. I don't want to do that. Is there a better way to? There's even a better way. How about I just get rid of the 4, put the 4 out front.
Smart.
Done with it. So the 4 is out front. I'm going to leave room because I'm probably going to need something else out front. Because I would like a 6dx to show up. So I can make a 6dx show up. As long as, like I can't just do that.
You multiply everything else by 6.
I need a 1/6 out front to counter the 6 that I put in there. But that's a small price to pay so that du,
So basically you're putting 2/3 out front.
yes, that turns into 2/3. 6x minus 1 was the u. So I've got u to the 2/3. And I have a 2/3.
Okay, we can do that.
Okay, so that was a little bit of, algebra and calculus acrobatics there to make that work. But I should be able to handle this now. Right, Ty? What's the antiderivative of u to the 2/3?
It's going to be 5 over 3u to the 5/3 divided by...
What?
I'm confusing myself.
So u to the 5/3.
Yeah,
Increase the power by 1.
I mean, you just do over 5 over 3, I guess.
Yes, I'm not going to put over 5/3. That wouldn't be wrong. What's a different way to... Let's do times 3/5. And then ignoring the 2/3 is already there. The 5/3 and 3/5 would cancel each other out. That's why we put it there. Oh, you made the same minor mistake that Austin did. Plus C. So let's see here. The 3's will cancel. And I need to replace the u with the x stuff. So 6x minus 1 to the 5/3 plus c. Not that many would, but what would you do to check that answer? How could you check this answer?
You take the derivative.
Take the derivative of it, and you should get back to where we started.
If you don't, then
If you don't, then you did something wrong. Number 3.
oh.
Okay, a little bit uglier, but again, I want to pick u to be something so that so that du shows up.
But there's no quotient rule when you're taking the derivative.
No, there's no quotient rule, so I'm going to hope that takes care of itself in a minute. Any ideas on what u could be? Even peeking ahead so that du would show up? If u is 2x squared minus 1, then du would be 4x dx. And that's not perfect, but it's pretty close. We can always fix a number, a coefficient we can always fix. If we're off by a power of x, you're not allowed to multiply by x and stick an x out front. That doesn't work. But any number you can fix. So I'm going to put a 4 on there, and then a 1/4 out front, so that 4x dx is now du. And I've got 1 over the cube root of u. Still don't really like that.
You gotta put the 1/4 back out front.
I do need the 1/4 out front still.
You could make it u to the negative 1/3.
Yeah, I need to change this to have a power so I could use the power rule. So let's make that u to the negative 1/3, the 1/4 out front. So it's not great, it's not super easy, but it's way better than where we started. So I should be able to antiderivative, Kyle, u to the negative 1/3. So what's the antiderivative of u to the negative 1/3? So it's the same rule we used on number 1 and on number 2. Increase the power by 1. So if I increase negative 1/3 by 1, 2/3, and then we divide by the new power, or multiply by its reciprocal, which probably would have looked better out front, but I didn't leave room, plus c, of course. So let's see, that's 3/8 u to the 2/3 plus c. But don't stop there. Common mistake to make it all the way there and then forget to put the x stuff back in there. 3/8 2x squared minus 1 to the 2/3 plus c.
The next one doesn't look nice either.
The next one doesn't look nice either. None of them look nice. If they look nice, you wouldn't need u substitution. Again,
This one looked kind of nice.
I'm hesitant to pull popsicle sticks for guessing u because it's tricky at first. We don't know it yet.
The bottom.
The bottom. So you want to use all of the bottom or just the x squared plus 4x minus 3?
Just the, yeah.
Yeah, if you use all of the bottom, then your du is going to be really ugly and too big. But if we let u be x squared plus 4x minus 3,
Then that's nice and
du is easier to deal with. 2x plus 4 dx. Well, I guess technically that should be in parentheses. Good news or bad news there?
good news.
Might say good news. Because I don't have 2x plus 4, but
You can easily make
I can fix it. I can put a 2 on there, and that would turn it into 2x plus 4. And then all of that together is du. Still have a 1/2 out front. And that turned into 1 over u squared. That's good. It's not great yet because I can't integrate until I have a power. So let's make that u to the negative 2 du. And then we can let Kristen integrate u to the negative 2. Increase.
-1.
Yes. Increase the power by 1, divide by the new power, plus c. Some people lay off the plus c till the very end. It's fine as long as you don't forget. The trick is if you plan to do that, by the time you get to the end, you've forgotten, and sometimes c doesn't make its appearance there. So negative 1/2.
plug in U.
I'm going to go ahead and skip a step and plug in u. 1 over x squared plus 4x minus 3 plus c.
That's a safe stop
That's a safe stop. You could distribute that 2
if you want.
to the bottom if you wanted, or at least write it together with the parentheses, but it's fine how it is.
Oh,
You're right. Looking ahead at number 5, O is the correct expression, because this one doesn't look good. This one is tricky.
U equals x minus 4 to the 1/2.
Okay, so there's a couple options. U could be x minus 4 to the 1/2. And then du would be 1/2 x minus 4 to the negative 3/2, which would be too messy.
Yeah, let's just leave it x minus 4.
Now, how about x minus 4 versus x plus 2? You want to use u to reduce the complication stuff. So the square root is the more complicated part. So let's let u be x minus 4. And then du is dx.
You don't have to worry about manipulating for du.
So that's an easy part. So this part is du. I'm going to rewrite the u stuff as u to the 1/2.
But then there's x plus 2.
But then there's x plus 2.
What do you do with it?
And this is where we get kind of creative.
We could multiply it by 2, negative 2 or something.
No, multiplying is not going to work because you can't. I mean, I see what you're trying to do. You're trying to make this match this,
Yeah.
but you can't get there.
Yeah.
Well, I don't like the x in there, right? That's the problem. So
It's just a number.
if I rearrange this equation, if u is x minus 4, then x is
U plus 4.
u plus 4. And so then in place of x, I can put u plus 4. Now, there's still a plus 2 there. That's what makes this annoying.
So it turns into u plus 6.
It turns into u plus 6
And then you can do it.
times u to the 1/2 du.
But then you gotta multiply because there's no.
Correct. There's no product rule for integration, so I need to distribute that u to the 1/2 before I integrate. So u to the 3/2 plus 6u to the 1/2 du. Now that was a lot of gymnastics to get there, but this is a much easier thing to integrate compared to what we started with. So Landon and Miguel. Landon, what's the antiderivative of the first one? What's u to the 3/2? 3/2. So u to the, yeah, you said it right. U to the 5/2 with the 2/5 out front. Yes. Miguel, how about the second one? Well, yeah, you could divide by 3/2 or multiply by 2/3. Yeah, it's the same thing, but multiply by 2/3 would be a lot easier. I'm really tempted to leave off the plus c for space, but I'm going to put it in there. Again, you can leave it off and stick it on at the end, but don't forget to stick it on at the end. So 2/5. Now I just got to plug the u stuff back in there. X minus 4 to the 5/2 plus 12 over 3 is 4. X minus 4 to the 3/2 plus c. Yes. Save stop.
Because I don't want to mess it up.
No, and you don't. And what the book does is awful. And we're not using the book, so you don't have to worry about it. But it's impossible to figure out your answer when you look at the book, because the book factors out x minus 4 to the 3/2.
What?
Right?
Okay.
Takes out, and then you get a big mess in there. You don't want to mess with that.
We're high school students, not.
Well, you should be able to.
Yeah.
But we'll leave it alone. All right, based on number 5, number 6 is kind of similar. Kind of only two choices, x minus 5 or x minus 6. Because you don't want to do square root of x minus 6, because then du would be a mess, and you wouldn't be able to clean it up. So what do you think, x minus 5 or x minus 6? X minus 6. The du is dx. Now we start plugging in the pieces. So dx is the same as du. Square root of u in the bottom. But I still got an x minus 5 in the top. And so it's okay to write what I just wrote. It's just a little bit ugly, and it's clearly not ready to do anything with because there's x's and u's. So I'm not ready to, it's okay to write it, but don't try to integrate that because you got x's and u's in there. So I need to get that x out of there. Well, what does x equal? What could I replace x with?
U plus 6.
So u plus 6 minus 5 over, I'm going to rewrite that as u to the 1/2. So still doing algebra here, u plus 1 over u to the 1/2. And there's still no quotient rule, so I need to divide each of those by u to the 1/2. So u to the 1/2 plus u to the negative 1/2. Algebra, 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 algebra here. But now I'm ready to integrate. Logan, what's the antiderivative of u to the 1/2?
D to the 3/2
Uh-huh.
over 3/2 or times 3/2.
Well, which one? Or over 3/2 is right, but I don't want to do over 3/2.
To multiply by 2/3.
I'd rather multiply by 2/3. On a free response question, you would be able to write over 3/2. Like fractions and fractions would be okay.
Alright.
Julia, how about the antiderivative of u to the negative 1/2? Yeah. So increase the power by 1, divide by 1/2, which is multiplying by 2. And I guess I can't blame either one of them because they answered the question I gave them. What am I missing though? Plus c. So let's put the u stuff back in there, or excuse me, the x stuff back in there.
What time is the bell ring?
1:54. What time is it? Oh, we got plenty of time.
What time is it?
To me, those are the hardest ones, 5 and 6. Like I feel like I try to just put those in the end. 7 and 8 aren't nearly as bad
It looks scary.
because you can antiderivative cosine.
Yeah.
What's the antiderivative of cosine?
Negative sign.
So the only thing I need to worry about is that 4x.
Yeah.
So let's let u be 4x because I can handle the cosine.
Okay.
If u is 4x, then du is 4 dx.
You multiply it by 1/4, so you can multiply it inside.
Yep, so I need a 4 on the dx, which means I need a 1/4 out front. And now I need the antiderivative of cosine.
Negative sign.
Definitely sine. Is it positive or negative?
Negative. Oh, wait, antiderivative?
The antiderivative of cosine would be positive sine. And I'm going to go ahead and plug in the 4x. So that one wasn't bad because the only thing we needed to fix was the 4. The only thing we were worried about is the 4. Number 8's pretty similar. Like, ignore the 10x. tangent secant,
Is
that is the antiderivative of, or that, excuse me, that's the derivative of somebody.
that's secant?
Yes. So, you know what? Let's try to bypass U substitution altogether. Secant of 10x, the derivative of secant of 10x would be tangent 10x, secant 10x. But I'm
Divide
off.
by 10?
I'm off by 10. So how do I fix my off by 10? I can do a 1/10 on the outside.
So technically divide by 10.
So to do it, if it really bugs you, you can do u equals 10x, du equals 10 dx, and kind of go through the process. But if it's only a coefficient, a lot of you will be like, I can kind of figure that out. Number 9. The number 9 will be the last one. So these are tricky because the derivative of sine is cosine, and the derivative of cosine is negative sine, so you're like, which one do I want to do? Do you know which one we want u to be? Sine. Because if you pick the other way, you end up having to cube your du, and I don't know what that would mean.
I mean, you could probably do it.
So this really turns into a easy problem if you pick the u correctly. Antiderivative of u cubed is u to the 4th over 4. U was sine, so I'll put the 1/4 out front. 1/4 sine to the 4th of x plus c. And I finally relented and did the plus c at the very end there. 10 is pretty similar. Derivative of tangent is secant squared. So I let u be tangent of x and kind of go from there. All right, today's assignment is worksheet 1. Let me pass that out to you.